Thank you everyone for joining. And today we are going to have a webinar on ChatGPT with all the buzz and the changes happening in generative AI. Since November of last year, ChatGPT has taken the world by storm and definitely a lot of interest. And there are some right and wrong ways of using ChatGPT, and hopefully we'll cover quite a bit of interesting stuff today in the webinar. So this webinar is brought to you by Big Data Trunk. I'm part of the Big Data Trunk team, and our just take a couple of moments to talk about Big Data Trunk. Big Data Trunk is a professional training services company founded in 2008. We are located headquarters in the Bay Area, California, but we do online trainings across the country, US, as well as different parts of the world as well. We provide soft skills and technology training in technology, as well as a lot of soft skills online and in person for corporates and individuals as well. Obviously, these are the various skills areas, a lot of technology focus, a lot of data focus, data, AI, cloud, DevOps, some of the emerging tech, IoT, blockchain, AR, VR, obviously the programming world, and then we have soft skills, leadership skills. We have at least a few dozen soft skills courses and programs available as well. A lot of focus recently has been around upskilling and reskilling corporate employees, whether it is bootcamp on data, diversity programs for women in data, and several different programs. So you can check out our website, bigdatatrunk.com, for all of those details. And what we are going to start is a more ChatGPT focused conversation, which is more relevant to this webinar. We have a lot of training in the generative AI space. So you can look at our website and just go particular category or tag for generative AI. And we provide Fortune 500 companies trainings in technology, as well as have some public trainings as well. And this is a small subset of our training offering for the generative AI. As you can see, a lot of buzz, and we have a whole range of training programs which are already coming in that area. We have around 300 plus different training programs, in general, AI being the most, which we have, and now generative AI is being the focus. So that was quickly brief about the screen.
So welcome, you guys. I'm glad you guys are here. I absolutely love this stuff. Like I said, sometimes you're live at exactly the right time. I love working with data, and it's just a crazy time if you get access to data and this generative AI. I don't know how many of you guys use ChatGPT. I will assume that some of you do, but not all of you. So we don't have a lot of time together, but I do want to give you a sense of not just, ChatGPT, but generative AI in general, you guys. It's just a different world. It will never be the same, ever, ever, ever. If you're not convinced of that yet, you soon will be, because you will have to be. It will change what you do going forward. I'll share more about that as we go. But I do want to give you a sense of this ChatGPT thing and a little bit about generative AI, because we don't have a lot of time. But I do want to share with you why the world is so different and what in the world is ChatGPT and large language models. And so I'm going to try to go slow because I don't know your backgrounds. If you do have a question, perhaps you can put it, maybe you can put it in the chat, or I don't know if you can admit yourself, you can put it in the chat if you have a question. But I will assume that you don't know much. But if you do need me to repeat something, or if you have a question, ask me, and perhaps at the end you could maybe submit that. Okay, so when we talk about ChatGPT, many of you have probably heard of a large language model, LLMs. And that's what I want to give you guys a good sense of that. Because we talk about ChatGPT, you guys, today, but who knows what we're going to be doing a year from now? Because it's so competitive. This is new, but ChatGPT may be like MySpace in 18 months. Just something that you all remember ChatGPT? Okay, I don't know who's going to win this, but a lot of people are chasing it. Amazon, Facebook has their Llama model, and Apple is doing some stuff. Google, of course, with Bard and their Palm 2 model. There's a bunch of stuff going on. So what I'm talking about will apply to any large language model, even though we're going to focus on ChatGPT. Okay? So first of all, I'm going to give you guys a little bit of a background in terms of machine learning. Not much, but here's what I want you to understand about all of this. How in the world can a machine understand language? How in the world does that happen? How can a machine do those things that we ask it to do? For those of you who've used ChatGPT, how does it do that? And so that's why I want to give you a sense of how it was trained, so you get a sense of large language models in general. So machines learn by example. That's what machines want from you. Machines say, just give me examples of your world. Just tell me about your world. I don't live in your world, but if you can give me examples of your world, I can learn it. I can learn it. You guys, a neural network can learn anything with enough data and enough time, if it doesn't require a lot of reasoning. And even now, with the generative models, it's even getting better with reasoning. But I want you to get, first of all, machines learn by example. So the way these models are trained, first of all, let me orient you. If you wanted to teach a machine how to differentiate between a positive and negative movie review, maybe that's your task. Your machine, I want you to know what a positive review is versus a negative review. I can't tell you what it is. I don't know. I mean, I know it when I see it, when I read it, but I don't know how to describe it to you, what a positive or negative review is. Okay. So you need to help me out. You just have to learn it. I can't code it. I can't tell you it. You just have to learn it. And the machine says, okay, I'm happy to do that if you give me examples. So you're going to collect a bunch of examples of movie reviews. And you say, okay, machine, this one's positive, this one's negative, negative, and positive. I've read through them. I know it because I've read them, but I can't tell you why I know they're positive and negative. I mean, that would always be true. So you're going to have to learn it. And so the machine learns by you just giving it as many examples as you can, as many examples as you can. Okay. And importantly, you give it a label. That's what we call a label. Okay. Just like your professor scores your test and gives you feedback. And so you can see, oh, now I see where I got that calculus problem wrong or right or whatever. I need feedback. And that's how the machine learns. You give me feedback. Just tell me if I'm right or wrong. And we do that with labeled data. And sitting in between your examples is some algorithm. It has nothing to do with you. Machine learning is not you. Okay. Some algorithm is going to sit between your examples and learn whatever you asked it to do. You have to come up with just a brilliant question and get a bunch of data or examples of the world and let the machine learn it. It's just, like I said, an incredible time if you can get your hands on data and ask great questions. So this right here, we call supervised learning because we're supervising the machine's learning like your professor or your teacher might supervise your learning. Tell me when I'm right. Tell me when I'm wrong. Feedback, knowledge of results. Tell me how I did. Okay. Same thing. You want to know about a cat and a dog? Give it as many cats and dogs as you can. I can't tell you, machine, what a dog is. I know it when I see it. I can't tell you. I mean, I know it, but I can't tell. I've never seen every dog, but I know it when I see it. So all I can do is give you as many examples as I can and give you labels. That's all I can do. But the problem, you guys, is supervised learning. It's expensive and time consuming to get a bunch of labeled data. If I wanted to get 1,000,000 images of cats and dogs, man, that would be hard because I have to get them and I have to pay someone to label them. And it's hard. But I do know that machines do better when they have a lot of data. So I'm torn. Do I give it accuracy by getting data and labeling it? Because I know that's going to be exactly what a dog is. Or do I not label it? That's what we call unsupervised learning. What if I don't label it? Then I can give it as many cats and dogs as I can. I'll go get you 1,000,000 cats and dogs right now if I don't have to label them. I'll just go scrape and get everything I can find on the internet and give it to you. And then we hope that the machine can learn patterns on its own. Maybe by giving it so many examples, it can start to learn what a dog is and what a cat is. That's our hope. Okay, so I'm going to come back to this supervised problem. Supervised tells the machine this is what humans want. This is aligned with what humans would expect. That's supervised learning. Remember, machine doesn't live in our world, doesn't even know what a human is. But if we can supervise, give it labels, it tells this is what humans would expect. Okay, but that's hard to do. So unsupervised learning, we can give it a lot of data though. So we're torn. We're in between those two. So we're gonna come back to this, but I do want you to know what supervised learning is. It means we have an answer key. Unsupervised learning is I've given you data, but I haven't told you what it is. And I hope you just can learn patterns on your own. Okay. One other thing I want to mention to you. Don't be intimidated by this. I'm not going to talk about a neural network. But before we did generative AI, and what I'm going to talk about in a moment, which is called a transformer, this is how we understood language, recurrent neural network, or LSTM, which stands for long short-term memory. But the way this would learn, all I want you to know is just very simple. It just takes words in sequentially. It just takes in one word at a time. So as you're speaking to Alexa, or as you're giving it some text to summarize a PDF document or whatever, it would just take in one word at a time, or to translate something, just one word at a time, one word at a time. That's what it would do. And so it's paying attention to the most recent word. That's the best thing we had, okay, until a few years ago. Okay, and I'll talk more about that. The problem with this model today, you guys, is this. If I give it what we call a fill in the blank task, because that's what these things do, they're just predicting the most likely word to go there. If I say Anthony, that's my name is Anthony, I say Anthony blanks reading, the machine has to learn what's there. Well, an LSTM, because it's paying attention to reading, remember it's paying attention to the most recent word. So it's looking at reading. And the LSTM, or the recurrent neural network, is saying, you know what? Most of the time when I've seen reading, I've seen that people don't like to read. In fact, they actually hate reading. So it's going to look at some statistical probability and fill in Anthony hates reading. But maybe I love reading. Maybe I'm an avid reader. If it could look and see, hey, it's me, it's Anthony, it's me. If it could look at me, it might say, oh, Anthony, oh, he loves reading. But it can't look at me. It's looking at reading. And that's what's changed everything. We need something that can look at the whole corpus. And this is what's changed the world, you guys, this transformer model. This was the breakthrough. This can look at everything. You can consider the whole text. This is what's known as a large language model. And this was developed by Google in 2017. And Google developed this for language translation. Google realized you can't take words in sequentially and translate. In some languages, the verb comes before the object. In some languages, the verb comes after the object. You can't take things in literally and translate. So they came up with this transformer that can pay attention to all of the text. And that changed everything. It can consider the whole text. This is what a transformer looks like. It's just a neural network. Don't worry about it. All I want you to know about a transformer is this. And this is true for just about any generative, anything that we do that's generative. Music, images, text, just about anything. Here's what I want you to understand about this transformer. It has an encoder. It encodes things in one language. You take it in one form, and it has a decoder. It decodes it into another language. It puts it out into another form. That's all I want you to know about a transform. That's one of the most important things about it. So instead of getting caught up enough to know the math and calculus and linear algebra and all that, just understand this. Google did a beautiful thing having to do with this. It's just incredible when you look back on it, that it has these two different things. But what's incredible, if you look in here, there's this thing called attention. It's the only thing that I'm going to mention in here is this thing called attention. That's what was revolutionary. Let me tell you what attention is. Okay, so again, the transformer inputs it in one form, outputs it in another form, but it's this attention here. Let me show you what attention does. It's called self-attention. And this was what's so revolutionary, you guys, about a transformer. Look at this sentence here. A dog ate the food because it was hungry. Okay, what is it referring to? That's easy for you as a human. That is so hard for a machine. What is it? Well, is it dog or is it food? What's it referring to? Now, you know it's dog. That's easy for you. That's hard for a machine. What about this sentence? A dog ate the food because it was delicious. What's it paying attention to now? I mean, what's it now? It's food. How do we do that? How in the world do we do that as humans? Well, the machine has to be able to do that. And that's what a transformer can do. What a transformer does with self-attention, it relates each word to every other word in the sentence. I won't get it has to do with a neural network and matrices, and I won't get into all of these types of things, but just trust me, it relates every word to every other word. And the word that has what we say the largest attention value, or the strongest connection, or the largest weight, it knows that it learns that that's what it is referring to. And so it can do like we do. If you had to step out of the room to take a call, you were talking to a friend, and she said, I'll be right. Well, let me take this call. I'll be right back. And she comes back 5 or 7 minutes later. Anyway, it was, what it is referring to. See, you can remember it. That was hard for a machine to do. Now a machine can remember it. It can remember context. You can hold a conversation with a machine like you can a friend. If she says, so anyway, I was saying that she was, well, who's she? Machine couldn't do that before. Now machine can hold the machine knows what she is referring to, or he, or it, or that. It can remember those things from that self-attention mechanism. Okay, that's revolutionary. Now, let's get over to let's talk about a generative model more specifically. Virtually all generative models are transformers. Okay, so when you think about generative models, think about the transformer. I don't care who makes it. Okay. When we talk about supervised learning, but it's difficult to get a lot of data when you do supervised learning. These generative models do what we call self-supervised learning. You guys, this is just crazy. This is wild. It does self-supervised learning. And self-supervised learning, it has the ability to train itself. And what it does is it generates its own labels on its own. Remember, give it a bunch of cats and dogs and let it figure out on its own. It will learn its own labels. And it can adjust those labels as it iterates, as it gets more examples of the world. Because remember, your job is to give the machine examples of the world. And as it sees more examples like a child does, it can adjust how it understands something. Okay. And the thing that's incredible about that, you guys, is that's how humans learn. Most of what we learn as humans is self-supervised. And I want you to get that, because that's why you'll see why ChatGPT, if you use it right, ChatGPT and these models are so amazing, because they learn the way we learn. For example, a child, okay, a child largely learns by observation and interaction with the world. That's how a child learns, whether you know it or not. Okay, a child just learns by watching and observing. It's self-supervised largely. The child will form some generalized or some generalized understanding or some hypothesis of how things work. And it can be modified with more interactions or observations of the world. For example, if you tell a child, this is an apple, this is an orange, the child will put that in machine learning terms in a class. The child doesn't know that. The child just knows this is a thing and this is a different thing. But in machine learning, we call them classes. Okay. So the child knows this is an apple and this is an orange. Then when the child goes over to grandma's house or goes to preschool, the child may encounter this thing. And the child's going to say, well, it's green and has a stem. I'm going to put it in this class too. That's all I know. I don't know anything else about the world. Then as the child goes on, the child sees this thing. The child says, oh, it doesn't have to be green. And the child may put this in that class. And over time, either on his or her own or by being told, the child might say, you know what, actually, this is a different thing. The child may put that in a third class. And the point is, you don't teach a child everything. You don't teach a child to lie. You don't teach it. If the child could only know what you labeled, the child wouldn't know very much. Most of what a child learns, what humans learn, is self-supervised. Let me give you an example. If you've never used a typewriter before, you could figure out how to use a typewriter. You don't need massive amounts of training. You don't have to start from scratch. You could self-supervise yourself to learn to do that. That's how a child learns. You'll figure it out. Just like a child who may be going through a grocery store and they may see something and so, oh, that looks like a fruit. I bet it's sweet. Maybe it's a cucumber. Maybe it's a tomato. The child's going to learn and will change that thinking. When they bite into it, oh, that's a lemon. I thought that was going to be sweet. And the child will learn. You don't teach a child all those things. Okay. And so the point is with these generative models, they learn how humans learn, and it's what brings AI closer to human level intelligence. And here's what I want you to know about ChatGPT and these large language models, you guys. And I'm not exaggerating. It was trained on everything, everything, all of the internet. There's only about 4 or 5 companies on the planet that can train these models because they're so large. There are millions of dollars to train, months to train, but they were trained on everything self-supervised. I can't label everything, but like a child, I can expose you to everything and you can learn it. And if you're wrong, you'll change your label on your own. Let me give you an example. I don't know if any of you guys know what this word means. Just think to yourself. I want to pause for a second. You don't have to answer, but I want you to be honest with yourself. Do you know what this word means? Canvas with 2 S's. I'm just being candid. I'm being honest with you. For me, I didn't know. I mean, I thought I knew what this word meant for the longest time. I've walked around most of my life thinking this word meant to cover an area. And some of you may know what it means, but I would suspect most of you don't. You might. Okay. I thought it meant to cover an area because no one taught me it, but the way I heard it is the police canvassed the area looking for the criminal. Okay. And I thought it meant they had the area covered. That crook's not getting out of that neighborhood. The police have it canvassed. That's what I thought it meant, to cover an area. But during the political season, you'll hear the pollsters canvass the voters. I said, oh, it means to ascertain opinions. Oh, they asked the voter, who'd you vote for? What do you think about this policy? The police went door to door canvassing the neighborhood. Oh, they went door to door asking, did you see anything out of place? Did you hear any sound about this time? I changed my label. That's self-supervised learning, you guys. I changed my label. No one taught me what the word meant. I thought I knew what it meant just by living and hearing the word. And as I lived more, I changed my label. No one taught me it. No one told me to change my label. That's self-supervised learning. That's how these large language models learn. They learn on their own. And it's just incredible. So now we don't have to label it, so we can give it the whole world. You don't have to label it. Just give it and let it figure it out like a child learns. Just put the child out there. A 15-year-old knows more than a 5-year-old because they have more examples and they can change their labels. And it's the same thing here. So when we talk about a generative model is self-supervised. Broadly speaking, just about every generative model is self-supervised. Okay, on its own. That's the only way we can give it all that examples of the world or data. Let me show you how they're trained so you can get a better appreciation of these large language models or specifically ChatGPT. They were given a bunch of text like this. And what they would end up doing is saying, I'm going to give you some text. You predict what might come after that. I'm going to leave off part of the sentence or part of the paragraph. You figure it out. You just have to figure it out like anyone else might learn something they don't know. Okay. Or they might drop 3 words here, a word here, a couple of words here, and say, figure out what might go there. That's how the word was, that's how it was trained. It learns probabilities. What's the probability that would go there? And you know what happens when you want ChatGPT to be creative? Like you want to create a poem or a song, you know what it does? If you use the API, if you don't know what API, let me just make it simple. You can tell it to predict the word that's most likely, the word that has the highest probability, or you can say randomly choose the top 10 words. That's how it gets creative. It doesn't have to, it'll predict a word. Oh, that's kind of cool. I would never have chosen that word for that verb or whatever. That's kind of neat that it came up with that. That's what it's doing. It's looking at probabilities. It has this probability distribution. And it can say, I can either give you the most likely or I can be a little creative. I can randomly pick something from my top 25 most likely words that would go there. And so that's how it becomes creative. It doesn't have to be so deterministic. It can kind of say, well, let me kind of play around a little bit and see what might be right. And so it can really be creative. The point is, it's just predicting the next word. That's all ChatGPT is doing. What's the probability of the next word? What's the probability of the next word? Okay. So, for example, if you gave it this is how it was trained. The blank chases the blank in the savannah. And as a human, you're going to put some words there. Just think on your own, what might you put there? You might put something like the cheetah chases the antelope in the savannah, or the lion chases the wildebeest, because that's what it's seen. It's probably not going to say the cat chases the mouse in the savannah because it hasn't seen that. Remember, it was trained on the whole of everything. It probably hasn't seen a lot of examples on the internet of the cat chasing the mouse in the savannah. So that's probably not going to be a probability that it makes. It seems so smart, but it's really probabilities, and it's really good at it. Okay, so it's going to probably say maybe the cat chased the mouse in the kitchen. It's more likely to have seen that. Remember, it's like a child's going to learn by living and seeing examples. Okay, mom makes her bed in the morning. What's the child? Do you see the child trying to pull the sheets or covers? They're just learning by what, and that's what this model does. If you're trying to do something, they're trying to do the same thing. They want to wear mom's high heels or what. It's the same thing. I'm just trying to learn from everything you show me. I can only know what you show me. Okay. Now let's talk about GPT. So many of you have heard of ChatGPT, but let's talk about GPT. This is what started all of it. GPT, you've probably heard of GPT-3. This came out in June of 2020. Okay, this is the first time I heard of it. It was out before that because GPT is version 3. There's GPT, GPT-2, and then this is GPT-3. This is the first time I had ever heard of GPT. And GPT stands for Generative Pre-trained Transformer. Generative. It creates something from nothing. It's generative, pre-trained. You don't have to train it like you would a normal machine learning model. It's already trained. You don't have to do a thing. Transformers from that beautiful Google transformer architecture. Generative pre-trained transformer version 3. Okay, that was June. Okay, a lot of people didn't hear about unless you're in data science and machine learning. It's kind of exciting because I remember these were the examples going around at that time. And this is an example. It would say, for example, this is legalese, some document you might sign for a mortgage or an apartment or rent or whatever it might be, business that you're starting. And it says here, plaintiff alleges on information and belief that defendants, blah, 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 blah. It's legalese. And GPT-3 could convert that into layman's terms. I thought that was so wild. That's just crazy. I said, is this a joke? Is it just kind of a canned example? Is that real? And then it could go the other way. My landlord didn't return my security deposit in the time allowed by California law, and it could convert that to legalese. That was 2020. I remember it was the height of COVID. I said, that is crazy. So here's what I want you guys to get. The first thing I want you guys to get is transformers do translation. That's translation. That's translation. You're going from legalese to layman's terms or vice versa. Google developed this for translation, almost all of generative AI is translation. It sat there since 2017, you guys. And it's just crazy what we're doing now because there's transformer. If you can put it in the form of translation, that's just translation. Instead of saying from English to French or something, it's from layman's terms to legalese or whatever. Okay, here's some other ways that it was trained. I love peanut butter and blank sandwiches. And they would tell it, Google, this is from Google's example, would say, okay, GPT-3, you think, or whatever it is, transformer, let's say, you think you know something. Okay, give me one word that would fit there. And this is what it did. This is from Google's website. I love peanut butter and jelly sandwiches. They said, okay, good guess. That seems good. Okay. Then they said, give me 2 words. And it didn't give it 2 words, gave it 3 words, but it said, I love peanut butter and jelly on my sandwich. It said, wow, okay. What about 4 words? Give me 4 words. And the transformer did this. I love peanut butter and jelly, which is what makes a good sandwich. You said, wow, that thing seems like it's really understanding language. So they said, give me 16 words. And it did this. I love peanut butter and bread. Thanks. This looks delicious. I love all types of peanut butter, but especially peanut butter jam sandwiches. And if you count that, that's exactly 16 words. And I want you to remember that because if you use ChatGPT, I hope you'll say, ChatGPT, tell me about taxes in 30 words or less, or in 3 sentences. You can be very precise because it understands that. That's how it was trained. Say 2 sentences, 3 paragraphs, 47 words, whatever you want to do. And it's very good at that. So keep that in mind. It was trained to do tasks like that if you're very specific in terms of guiding it. Next thing is next sentence prediction. Another way that it was trained. They would give it a sentence. Okay. I love the Bay Area. They'd give it the very next sentence in the corpus. The weather is often pleasant. And they'd ask the transformer, can those sentences follow each other? See if it understands language. It would say, yeah, they can follow each other. They give it another sentence. I've been looking forward to this trip. And then to go get a sentence out of a totally different corpus randomly. I'm not sure if dinner's ready. And it could identify those who wouldn't follow each other. So these are the ways that it was trained, how it knows language so well. Okay. Now let's talk about ChatGPT. That was GPT-3. That was in the summer of 2020. Okay. ChatGPT, also known as GPT 3.5. And this came out in November of 2022. Some of you may know, just last, not what, 8, 9 months ago, maybe 9 months ago. It's called GPT 3.5, okay? Also known as supervised fine-tuning. Remember that supervised learning is the best thing we have? Now it comes back. What OpenAI said is, you know what? This GPT-3 thing is really good. It knows language really well. But let's fine-tune it. Let's supervise fine-tune it. Just fine-tune it a little bit with some supervised learning. We don't need to give it as many examples now that it has a foundation and knows it well. So look at how ChatGPT was trained. As people were using GPT, they would submit prompts, right? And you might submit a prompt. Prompts are the questions or whatever, the instructions you would submit. Explain the moon landing to a 6-year-old. And OpenAI kept those to train on. And so they would randomly sample a prompt. Remember, it's still GPT-3, hasn't turned to ChatGPT yet, which is GPT 3.5. This is GPT-3. So they would sample a prompt. And they hired 40 contractors or labelers. And what these labelers did, they would write an answer, something that would be a desirable response for ChatGPT. They say, hey, ChatGPT, if you see something like that, you know what might be a good response? Blah, 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 blah. That would be good. And this would be a pretty good one too. And this would be a pretty good one too. So now it had examples. So now it became supervised learning. GPT-3 was trained with supervised learning. That's what made it GPT 3.5. It's called supervised fine-tuning because they had some humans step in now and give it some answers to say, just so you're aligned with humans, let me help you out just a little bit. Just fine-tune you just a little bit, okay? And so now what they said, ChatGPT, now that we've helped you out, GPT-3, as you advance to GPT 3.5, here's that prompt, or here's some prompt, provide some responses for us. And GPT 3.5, or as we know ChatGPT today, but at the time, it was to become GPT 3.5, it would output 4 to 6 responses, outputs, what's called completions. And remember those labelers that they hired? They would rank them. They'd say, you know what, this is a pretty good one. This one's not bad. This one's okay. This one's pretty bad. Yeah, no, that one's not good at all. And they would put them in order from best to worst. And then they use what we call reinforcement learning. And so that the model learns to return a response that maximizes its reward. It was trained, it's called reinforcement learning with human feedback. Like you might tell a child, hey, eat those vegetables, you might go get some ice cream later. The child's going to maximize its reward. It's the same thing with ChatGPT. They'll try to give it examples, and so it would output something, they would try to steer it or align it with what we want by doing what we call reinforcement learning. Okay, so now it's GPT 3.5, and it's released in November, commercially known as ChatGPT. Now, in March of this year, GPT-4 was released. Okay, GPT-4 did a few things. It reduced hallucination. If you know what hallucination is, I won't have the time to go much into that. But GPT-3, just like many machine learning models, are like a young child. So wants to be right for you. It so wants to be right. It does not want to be wrong, so it might lie. Not lie. It's just like if you tell a child, "Where'd you get that jacket?" The child's scared. The child doesn't know the right thing to say. Should I be wearing my friend's jacket, or do I lie and say, "This is my jacket"? They're scared, and they make up something. What we call hallucinating for a machine. But for a child, we just know they're scared and they don't know the right answer to say. And so they just say anything, even if it doesn't make sense. I bought it. My teacher gave it to me or whatever. And that's what GPT 3.5 would do, it would hallucinate. It didn't have the answer, so it just cobbled together a bunch of stuff that it knew and tell you, I'm telling you, Alaska is in Europe. It would just say that convincingly. And so GPT-4 doesn't do that as much anymore. It's more aligned. Now, people have said it's not as creative as it used to be. Some of its performance has gone down, and some people don't like that. As you put guardrails on and reduce hallucination, some people complain of creativity. And so there's got to be a balancing act, you know, because there's some pros and cons to all of it. Creativity versus, saying something that might be offensive or whatever, or hallucinating, all that has to be balanced. But it's much better at math. It's much better at reasoning tasks. You have word problems or reasoning tasks that you want it to work out. It's excellent at that, infinitely better than 3.5. It's excellent at coding, and it's really good at legal text. Those are the things that they say that it's better at. Another thing is it's a multimodal model. It can understand images, can output images, can still only output text, but you can give it an image and you can ask it a question about that image. It can see that image and understand it. Now, just so you know, GPT-4 is also known as ChatGPT Plus. Okay, you hear people say ChatGPT-4, there's no such thing as, but people, I mean, whatever. But it's GPT-4 is the model, and the commercial name is ChatGPT Plus. GPT 3.5 is the model. Commercial name is ChatGPT. Doesn't really matter. You guys will know what's being said. Point is, ChatGPT Plus or GPT-4, people will use them interchangeably, can understand images. So if you give it an image, you can ask it a question, say, hey, what are a couple of meals I can make with this thing right here? And it will understand an image, and this was its response. It'll tell you. I think that's another incredible thing that it can do. And we're just getting started. Google has now released, but in fact, both of them are kind of competing to release these multimodal models instead of just doing text, image, music, all kinds of images, all kinds of things. These because right now they can't output images. They can only understand images, but not output images. But I guarantee you that's coming. Okay, when it gets competitive, things accelerate. Now, here's what they put out in terms of how it understands tests. There's some tests that they tested all of them on. GPT 3.5 is in the blue, GPT-4 or ChatGPT Plus is in the green. And on AP Calculus, GPT 3.5 didn't score, and GPT-4 or ChatGPT Plus scored above the 40th percentile. For the bar exam, ChatGPT 10th percentile, ChatGPT Plus or GPT-4 90th percentile, and on the GRE verbal, GPT 3.5 or ChatGPT 60th percentile, and GPT-4, GPT Plus, ChatGPT Plus, virtually perfect. Just show you some of the differences in the model. I think GPT 3.5, the free version, is outstanding. But if you have certain use cases, 4 might be worth your time. If you're just doing general stuff, they probably don't matter. You may not know. Now, let's
compact and very informative discussion and conversation. So we'll open up for Q&A in a bit. I'm sharing some links in the chat and just want to take a couple of minutes to just share about the next event and a few things which people have asked in the chat. So hopefully you can see my screen with the meetup links. I put this links. We have several different meetup groups. So the Big Data Trunk, and some of you have joined, a lot of you have joined through this particular meetup, but we are also a Google partner, and we officially are organizers for Google Cloud Santa Clara and Google Cloud Santa Clara without the cloud and general stuff which we do. GDG is Google Developer Group. So these are official group Google runs. So we have several meetups you can join, whichever would make sense for you. I've shared these links, and we keep posting our events depending on what they are in one of these meetups. So you feel free to join that. The next particular one we are posting is on basics of data science. So generally going in data science, it's around a month away on 19th of October. Again, this link is posted in the chat. You could register to that. Several of you have already done that. So great. And that's what we'll try to keep a cadence of a monthly frequency. There are also other things, if you want to take this experience further beyond, what Anthony does is a full-on, more hands-on session where you really get to interact with this tool and build onto it and kind of see how the power of can be used. So there is a ChatGPT training and several other trainings which we have for public. We mostly do corporate trainings. In fact, these are for one of our corporate partners, actually Stanford, and we open up for public as well. We have that relationship with them, and we can do that. So these are a couple of trainings which are coming, depending on interest. If you want to take the journey, get into more of the actual hands-on interactive discussion, that would be an option. Also just want to share the fourth link where if you are curious about more of the generative AI, what's happening in the courses, whether it's for you, for your company, as small group of 3 and plus, we do online and in person. So all of that is available. Use whatever it's applicable to you or not, however you feel for it, but it would really great to see that people coming into the group, and very, very useful information. Thank you, Anthony, for the wonderful session. I'm going to, but otherwise, we look forward. I think it's a great presentation, Anthony, and I think look forward for you in the future events or in some training as well. So thank you very much.